let's discuss about square and square roots. We've heard a lot about squares in mathematics. Everywhere we go, we hear about 1 square, 2 square, a square, x square, and we hear about square roots, which is root x, root a, root 4, root 25. We hear a lot about these things. So let's get to know what is square and what is square roots in math. So first of all, what is square of a number? Square of a number gives us the result when we multiply that number by itself. Here we could see a very clear representation. When we are multiplying 1 with 1, we get 1. So we could say that 1 square is 1. Now, when we are multiplying 2 with 2, we get a number 4. So we could say that 2 square is 2 into 2, which is 4. In the same way, if I'm saying we have a number n, then n square would be equal to n into n. Now we have the concept of a perfect square or square number. A perfect square or a square number is obtained when we multiply a whole number by itself. So, this is what we explained the square here, right? You will get to the point of it when we are talking about square roots. Because what is the root of 5? So, square and root have a relationship. We could say that 5 into 5 is 25 or 5 square is 25. At the same time, we could say that root of 25 is 5. So, for that way, what is root 5? We don't know. But here we know that 1 square is 1, 2 square is 2 twice the times of square, which is 4. 3 is 3 times the square of 3 times 3, which is 9. 4 square is 4 times 4, which is 16. So these are known as perfect squares. Now let's see the properties of squares. A number having 2, 3, 7 or 8 at unit place is never a perfect square. So why did we say that? Let's get back to the first slide. So these are the perfect square we have. We have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Do you see any numbers like 2, 3, 7 or 8 in the ones place here? No, we don't. So, we could say that a number having 2, 3, 7 or 8 at unit place is never a perfect square. The number of zeros at the end of a perfect square is always even. For example, I am taking a number like 2600. Is it a number is it a perfect square? How do we check it? Normally, if we get a chance, we have different methods to check whether a number is a perfect square or not. We do a different methods which would be explained in the lesson later. But right now, we have a property of a square saying that, 2600, if it ends with even number of zeros, it could be a perfect square. It could be a perfect square. It's not always given that it's a perfect square, but it could be a perfect square when the ending zeros are even. But at the same time, if the number is ending with odd number of zeros, say 250, it's not a perfect square. We could just say that it's not a perfect square when it's ending with odd number of zeros. Now, the units digit of the square of a number is the units digit of the square of the digit at the units place of the given natural number. Now, this seems like a lot. It seems like a mouthful to say. But again, read it carefully. The units digit of the square of a natural number is the units digit of the square of the digit at the units place of the given natural number. Okay, so we have the square of 0. What is 0 into 0? 0. What is the square of 1? It's 1. What is the square of 2? It's 4. What's the square of 3? It's 9. 4 square is 16. 5 square is 25. 6 square is 36. 7 square is 49. 8 square is 64. 9 square is 81. And 10 square is 100. So we could see that 0 is at the ones place, we get 0 in the square, in the unit place. For 1 and 9, we have 1 at the unit place. For 2 and 8, we have 4 at the unit place. For these number 3 or 7, we have 9 at the unit place. 4 or 6, we have 6 at the unit place. And for 5, we have 5 at the unit place. So when we see the unit place of a given square, we could determine which might be the unit place of the square root of the number. Now, the fifth property of the square. The squares of odd numbers are odd and the squares of even numbers are even. Why? Let's see. What is 2 square? It's 2 into 2. That's 4. What is 3 square? It's 3 into 3. Just 9. We are just multiplying a number with itself. So, if we are multiplying an even number with another even number, we get another even number as the product. And the same applies to the odd number. Square numbers can be expressed as the sum of consecutive odd numbers. So these are the 6 properties of squares. Now, how to check whether a number is a perfect square? Let's see. Write the given number as the product as prime factors. Group the factors in pairs such a way that both the factors in pair are the same. If there is a factor which is ungrouped, then it's not a perfect square. Take one factor from each group and multiply them to get the required number whose square is given number. So, I'm not making it complicated. Let's solve an example and see how this works. So, we have 256. First, what we do the prime factorization. What is the first prime number we could factorize with? 2. So it could be 1, 2 2s are 4, 16, 8 2s are 16. Again, I could do it with 2. It's 6 2s are 12 and 4 2s are 8. Again, I could divide by 2. It's 3 2s are 6, 2 2s are 4. Again, with 2, we get 1 2s are 2 and 1 balance 16. Again, with 2, 8. Again, with 2, we get 4. Again, with 2, we get 2. And again, with 2, we get 1. This is our goal. We have to reach 1. So, how many times did we multiply 2 here? We said 2 into 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 how many 2's? 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8 number of 2's. So 1, 2, 3, 4, 5, 6, 7 and 8. We have 8 2's. Now we group them as a pair. So 2 raised to 2 into 2 raised to 2 into 2 raised to 2 into 2 raised to 2. We could see them as a pair, so we could call it as a perfect square. If it's not a perfect square, we'll have a number hanging around here without a pair. Now, the Pythagorean triplets. So, we all know about Pythagoras theorem. If we don't, it's a pretty much basic, very simple theorem considering a triangle, considering a right triangle, and we all know that in a right triangle, this is the base, this is the altitude or height, and this is called the hypotenuse. How do you find the hypotenuse? Hypotenuse is the side which is opposite to the 90 degree. So, Pythagoras theorem just says that the hypotenuse square is equal to the base square plus the altitude square. So here A is the base, B is the altitude, and C is the hypotenuse. So here we could say that C square equals A square plus B square. So what is Pythagorean triples? Pythagorean triples is a group of three numbers that can represent the side lengths of a right angle triangle. So basically Pythagorean triplets are A, B and C. So when you square the lengths of the two shorter sides and add them together, that is A square and B square, the result is equal to the square of the length of the longer side or the hypotenuse, which is the C square. So what is an example for this? If I am taking a triangle with base 3 and altitude 4, what would be the hypotenuse? The hypotenuse would be the square of hypotenuse would be the square of 3 square and 4 square. 3 square is 9 and 4 square is 16, which gives us 25. So hypotenuse would be equal to root of 25, which is 5. So the Pythagorean triples would be 3, 4 and 5. Now moving on to the square root. We actually have talked a lot about square root while we are mentioning squares. We just said that if 2 into 2 is equal to 4, which is also known as 2 square, root of 4 is said to be 2. Got it? That is 2 square is 4 and root 4 is 2. In the same way, 3 square is 9 and root 9 is 3. You get how this works? 3 square becomes 9 and root 9 becomes 3. So, what are the properties of square roots? If the unit digit of a number is 2, 3, 7 or 8, it does not have a square root, which we have. This is the same property we have told in the squares. Square root of even numbers is even and odd numbers is odd. Now, square root of a perfect square by prime factorization. Now, how do we find the square roots? How do we find the square roots of numbers? We have two different methods here. We could do it either by prime factorization or we could do it by long division. So, if we are doing it by prime factorization, find the square root of 1764. We could do it with an example. We have 1764. Now, let's resolve it into prime factors. It's an even number, so 2 first. A2 is 16. 1 balance 6, A2 is 16 and 2. Again 2, 4, 4 and 1. So is it divisible by 3? Yes, 4 plus 4 is 8 and 8 plus 1 is 9. So 3, 1 3s are 3, 1, 4. In 14, 4 3s are 12, 2 1 7. So is this divisible in 3? So 7 plus 4 is 11, 11 plus 1 is 12 and 12 is a multiple of 3. So again 4 3s are 12, 27, 9. So is this divisible by 3? 9 plus 4 is what? 13. It's not divisible by 3. Now what is the next prime number? It's 5. So is it divisible by 5? It's not divisible by 5. Now next one is 7. Is it divisible by 7? Yes, it is. It's divisible by 7 in 7 times. So again, we have 1 7 is 7. So we got it. We have 2 into 2 into 3 into 3 into 7 into 7. So we could write it as 2 square into 3 square into 7 square. Now we choose each one of these, that is 2 into 3 into 7. What is this? 6 7s are 42. So we got the answer as 42. This is how we do the prime factorization method to find the square root of a perfect square. Now, square root of a perfect square by long division method. What do we do in here? How do we find the square root of a perfect square by long division method? So, if you're reading what it's written here, it's written that make pairs from units end, find the perfect square which is equal to or lower than the rightmost pair, multiply above and add below the box, subtract product from number above it, get the next pair down, same box above and below, trial and error. It seems a lot confusing. So let's see how it's done. We got an example here which is a quite huge number, which is 390625. Now, we make it a pair, we pair two numbers from right to left. So it's like 25, 06, 39. And we put a bar on top of them to just know that, it's a pair. Now, we are doing a division as mentioned in the long division. So first of all, we're checking a square of a number which is equal to or just lesser than the number or the pair which is in the leftmost corner, which is 39. So which is the perfect square which is very close to 39? We all know that 6 square, which is 36, is closer to 39. So we put 6 here in the divisor and we put 6 here on the quotient. So this is what is said when I say that make pairs from the unit end, find the perfect square which is equal to or lower than the rightmost pair. Now multiply above and add below. So now we add this number here. This is 36, we subtract it from here like normal division. We add it here. We have 6 plus 6, 12. And we put a blank box both here and here. Now when we subtract this, we get 3. And just like normal division, we put this pair down. So now it becomes 306. Now, we should have a box here, right? So that we should find the quotient here. So now we know that 1, 2 into some number multiplied by this same number gives us 306. So what could be the number? Let's see. We are using trial and error here. So if it's 122 by into 2, we get 4, 4 and 2, 244. Let's see 123 into 3. 3 3s are 9, 3 2s is 6 and 3 1s are 3. 369 is very much greater than 306. So we take the number as 2. So this is 2, this is 2 and this is also 2. So let's clear the way out. Okay. Now, so we got, again, same procedure we'll do. 2 times 122 is 244. We add here, we get 124 with a blank space. Again, we get a blank space here and we subtract 306 minus 244. 6 minus 4, 2, 10 and 2, so 62. We get 62 here and we put the 25 here. Now, what should be filled in these boxes? Again, we see that 124 into something into the same number should give us 6225. Just because it's 5, let's try 5. 1245 into 5 gives 5 5s are 25, 5 4s are 20, 22, 5 2s are 10, 12, 5 1s are 5 and 6. Yes, we got the number. It's 5. Now, 625 times 5, 1245 gives us 6225 and the answer becomes 0. the remainder becomes 0. So what is the square root of 390625? It's nothing other than 625. This is the long division method. Now, square and square roots. Formula for finding the number of digits in the square roots of a perfect square. Okay, this is a very easy thing to do. We have 2 square equal to what? 4. We have 2 raised to 4 equal to what? 4 into 2, 8, 8 into 2, 16. So, if any perfect square contains n digits, so this perfect square contains 1 digit. This perfect square contains 2 digits. N, then the square will contain, like this square would contain n by 2 digits when n is even and n plus 1 by 2 digits if n is odd. So we get that 1 plus 1, 2 by 2 is 1 digit in here, in this place, and again if we do the thing, 2 by 2 is 1 here. Let's see it with another square. 12 square, we know that 144. So what about this? 144 have 3 digits. So 3 plus 1 by 2 is 4 by 2, which is 2. We have 2 digits here in 12. This is what it means. Now, product of square root of product of numbers and natural numbers. Product of square root is equal to square root of the product. So there's nothing to define in it. It's basically saying that root of AB is equal to root of A into root of B. If I'm saying that root 4 into root 16, it should be equal to root of 4 into 16. Now, if you want to check it, we could check it. This is 2 and this is 4. This gives us 8. And 16 into 4, 6 4s are 24. 4 2s are 4 ones are 4. 4 plus 2 is 6. Root of 64 is 8. So this is the rule. Now, let's move on. Make the square root of numbers in decimal form. So, decimal form is the same as long division method. If we have a decimal, say like 1.3025 and all, we could do the long division method here, but with the decimal point. That is, in the quotient part, we put the decimal point here. Other than that, we follow the long division method and we get the answer. Now, square root of number in fractional form. This is the rule which we have explained earlier, which says that root of AB equal to root of A into root of B. Just like the same way, root of A by B equals root of A divided by root of B. Now, this is all about square and square roots of numbers.